says that my computer's like almost out of storage. So hopefully I'll just grab this later from the cloud. Okay, welcome to class, each and every one of you awesome coders. Hope your weekend was fantastic. I'm gonna do that's there we go. All right, hope everyone's weekend was fantastic. Hope you're ready to do this thing, more SQL today. So grab your coffee, grab your snacks. We're going to be going through a lot of SQL. Hopefully the first class gave you a good introduction of what it is, what it's useful for, and a friendly just what do we call it, interaction to just get yourself acquainted with SQL. I know there's some people out there that said they're actually acquainted with Excel that helps them out, and people have actually gotten into SQL beforehand. So for you all, I hope this is a good refresher as well. So before we do any of that, as always, you know the thing. It's going to be the announcements today. So today's announcements, number 3 assignment is due, if you didn't already know that. So make sure that you are working on that. If you have any problems with it, any knowledge gaps, reach out to those TAs, reach out to the colleagues, reach out to me, and we are all happy to help. We are here together. We're trying to cross that finish line together. So reach out, get those assignments finished, and yeah, that's really it. And then start looking at assignment number 4. That's the big thing. Also, because I like to always come bearing gifts, I have a present for all of you. I know that a lecture 12 was not put up. Unfortunately, I wasn't able to get a recording for that one. So what I did for, I believe it was models and model bindings, is I just put up my past lecture for that for the previous class. Yes, I know you weren't my first class, so I put up my first class's lecture. So it's not going to be as fun for all of you, but hopefully it'll still have that information there that if you have any questions about models or model binding or just want more reflection on it, I typically go through the very similar examples in all of the lectures. So feel free to check that out. It should be, if you are looking for it, it should be under the Java lectures playlist, and will be a lecture 12, I'm pretty sure. Lecture 12 or lecture 11, whatever models and model binding is, that's the one that was missing beforehand, but it's up now. Other than that, all the other recordings should be out there. The studio for tonight will be released at 8:15 like usual. And that is my spiel for right meow. Any questions or anything, comments? Someone talk to me, because everyone's got their camera off. How? Anybody got any questions about assignments or announcements or anything like that? If this is gonna be a silent lecture, I swear I'm gonna just sign off right now and you all can do it on yourself. Just
Sorry,
kidding.
guys.
That was an empty threat.
I
Thank you.
don't know.
Thank you.
Models and
All right.
validation with lecture 12.
I also have been having
Awesome.
trouble remembering to do attendance codes, so I'm behind on attendance. What do I do?
You're going to want to reach out to Greg, Amy. He will have all those passcodes. I have zero idea what they are. So reach out to him.
Okay.
He'll help you out.
Donka.
Absolutely. Absolutely. Oh, forgot all my German. Yes. I used to take German on the Duolingo app for a little bit, but I broke my...
It's Bitte.
That's terrible. Bitte. Thank you. Bitte.
You're supposed to say danke.
She said Donka.
No,
is
Donka is
you.
what I said. Donka is thank you.
Yes,
Bitte
thank you.
is please and you're welcome.
Yes, it is really interesting. I always thought that was cool that they have the same word for please.
Yeah. Also, you know the in sign language, the sign for mom is actually fairly similar to the sign for the name for a female dog. So you have to be very careful of where you actually put your hand, so that so you don't say a bad word instead of mom.
Gotcha. Well, the more you know. So thank you. I will look out for that whenever I do start learning sign language. I know a few letters. I don't spell my name, but that's about it. All right, everyone. Awesome. Thank you for turning on your cameras. Now I have people to look at. Great. All right. Enough of me babbling. Let's get started.
One other
As
thing
always,
is more is very similar to another bad word.
I will keep that in mind. All right, let's get back to the coding portions. Help me out here. As always, we're going to start class with you talking to me. Yes, I just babbled for at least 5 minutes. Time for you all to babble. If I want to get data from a table, I would use what keyword? We're talking SQL here. What keyword do I use?
Select.
Select.
We are going to be using select. Very good. Yes, select is correct. Let's keep going here. I need to add the annotation blank to create a JUnit test. What annotation do we work with?
At test.
Very good, at
Yes.
test. We should be very familiar with that one after the past 2 assignments. So yes, at test. Awesome job. All right, when I want to protect code against an error, if there's an error that occurs, I would use a what?
Catch.
Catch.
That's it.
A catch, but also referred to as a try catch. So catch is the second part, try is the first one. We have a try statement, then a catch underneath. Very good. So that's how we would protect against an error. Fantastic, everyone. Let's keep going. If I wanted to create a string in SQL, well, that's supposed to be I'd use a
Varchar. Varchar and the
varchar.
character
Very good.
count.
Bonus points. How high can a varchar go?
256. 250. 256.
Close.
255.
255.
Very good. 255. Awesome. When I add the blank tag, it starts creating a website. What tag do we use to create a website?
HTML.
HTML.
Very good. HTML. That HTML tag builds that website that we see. That's the one we start and end with always. Of course,
The correct
excluding
answer
site,
for
very
the
top.
how far a varchar can get is actually FF, because you can also do it in hexadecimal.
You can technically do an hexadecimal. Hexadecimal FF is equivalent to 255, depending on what base number you're at. So very good. Yes, hexadecimal is base 16, while our typical system is at 10. So yes, both are true. Awesome job. All right. If
Why
I
are math
send-
jokes funny in base 8?
I'm sorry, what was that?
Why aren't math jokes funny in base 8?
Oh, why not, Amy?
7, 10, 11. It's 7, 8, 9 converted to base 8.
Oh my gosh, I love the
There are only
tricky
10
areas.
types of people in the world, those who understand binary and those who do not.
Very good. All right, let's keep it focused here. If I send a request, the blank receives it. So if I send a request, who's going to be that person that's going to be taking in those requests?
Server.
Part of the server, but we're looking at the MVC model here. Out of M, V, and C, who's going to be taking in those requests?
You?
I think I heard, yeah, there you go. The controller. The
Oh.
controller. So yes, the controller is the master of all requests and responses. It comes in as a request and the controller sends it out as a response. Fantastic. Yes, controller is it. If I want to contribute two, or if I want to combine two tables' data, I would use the what?
Join.
Very good. Yes, the join. Awesome. We haven't really gone over this. So let's go ahead and deep dive a little bit more into what this join actually does. So if we want to actually mix our data together, we're going to be exploring how to do that today. In order to do that, we're going to bring back the tables that we worked with before. So the table, the first one we were working with last week was the dog table, as always. Our dog tables have 3 columns: the dog ID, dog name, dog age, dog owner, and is good dog, with the corresponding data types as such. With the is good dog is a Boolean, by the way. Of course, remember that Booleans are saved as 0s and 1s. But today we're going to be bringing in another table. We saw it at the very end of class. This one is going to be the owner table. And this one, we have an owner ID, an owner name, an owner city, where they're at, and an owner age. How old are they? Now, the question is, if we wanted to get more information about our owner, all that information is locked away in the owner table. However, the owner's name is in the dog table. We have 2 separate tables, 2 separate entities here, and we want to attach this information. Now, in order to do this, like we said, we were going to do the join here. Joining data, as we just saw in the previous table, joining data allows us to take a little bit of information from a previous table and attach it in such to a table that has more information about that little thing. What do I mean by that? Kyle is the dog owner here in the dog table. Kyle is the individual who owns the dog, but I want to know more about Kyle. So of course, I mean, wow, this is very like boastful of a lecture right now to everyone. I want to learn more about Kyle. I want to learn more about me. So I would go to the owner table and look at that to get more information. Where does Kyle live? What is their age, etc. So in this regards, that's why we're going to be using that join today. So before any of that, we need to be able to create these two tables that we see here. So before we get into anything, what we're going to do is we're going to come over here to our stuff, and I forgot to drop these, so I'm going to do that right now. We're going to create our two tables that we're going to be working with right now. What I'm doing right now to drop these, I didn't want you all to see this, but I'm going to do it anyway. I right-clicked, press drop table, and it says, do I want to look at the query in order to drop this? I do not. Just drop it, please. Thank you. All right, let's go ahead and we are going to start building these tables. So just to save us a little bit of time today, I've created the SQL that we've seen before, but we're going to go over it real quick to see how we're going to be building these tables. This is the first one right here, create table, then our table name, and then we have our 5 columns that we're going to be creating today. The dog ID, dog name, dog age, dog owner, and is good dog, which is a Boolean. What I'm going to do here is highlight it, go up here and press that little lightning bolt. This runs the query. We come down here and we see that we created the table. Again, we don't see the table created here because once we create the table, what do we need to do? We need to refresh. Always make sure you're refreshing your tables. Otherwise, you might have a bad day. We don't want to have that bad day. So we create that table, we refresh it, and now we open this up and we see dog table there. Awesome. So I'm going to go over into the far right icon here, and this is going to allow me to see my table that I just created. You've seen all this in last lecture, but we're just going through it real quick. I come in here, I see that there are no entries provided. Well, that's because we just created the table. We haven't done what? We haven't inserted information into our table. So that's what we're going to do next. So what we're going to come down here is that I have 2 dogs created. We have Waggy and Odie. What we do first is we're going to do this insert in for Waggy and then the second one in for Odie. Now, one thing I wanted to show you, if you want to run 2 queries at once, what you can do is highlight them both and then press that lightning bolt again. This is going to run both queries at the same time. Saves me a lot of time, and that's why I like it. So we're going to go back over to our dog table, rerun this query, and we now see both dogs have been inserted into the table. Any questions on this? Any questions at all? All right, everyone's like, nah, Kyle, come on, give us something juicy, give us something hard to work with. All right, calm down. Let's first create the other owner table. We have 2 owners we need to make here, Kyle and Sarah. So what I'm gonna do is go back over to those queries here. And now we are creating this table for our owners. It's gonna have that owner ID, which is an int, owner name and owner city, which are varchars of 100, and then our owner age is an int. And then we have our 2 inserts down here for Kyle in St. Louis and Sarah in San Diego. Save us time, I'm gonna highlight all 3 queries and press that lightning bolt. Just like that, we have successfully created our owner table right there. I'm gonna go and query that owner table using the select keyword as always. And we press that and bam, we have all of our information in our owner table. Cool, we have all this information between the 2 tables. So everything is there. Now we have to attach it. How we attach that information, as we've already talked about, is joining. But there are a few different kinds of joins that we need to talk about today. The first one is the inner join. The inner join might be the more common of all the other joins out there. Inner join essentially connects information together that is related in the 2 tables. So we only connect the information that we have in common. Now, what do I mean by that? If we look at these 2 tables right here, and we want to match on the only thing that they have connected, the dog owner and the owner name, which are both Kyle, when we run this inner join, only Kyle and Waggy will be returned on the same line. So that information, everything we have in common, will return from the query. Well, things that aren't in common, aka Odie with the owner Teresa. Teresa is not in the owner table, therefore it won't be returned. So this is what we mean by only the data that they have in common. Only things that are true to the conditional, which we'll talk about in a bit, actually get returned. So these 2 would actually be returned, and Waggy and Kyle would actually be shown in our query results. This right here is the inner join. Let's talk about the next one. Next one is called the left join. The left join indicates the left table and bringing in all information in from the left-hand table while still trying to match it with the right table. Okay, now pause. Left and right joins can kind of get confusing. So let's talk about our lefts and rights, which by the way, up until about age 12, don't judge me here, I got 50-50 of them right. I was terrible at my lefts and rights. So I'm gonna try to get you all to get a little bit better at the lefts and rights when it comes to tables. In this scenario, the left-hand table is going to be the dog table. The left table is determined by how you write your query. This can be very confusing as we go through our query. So I do really want to make a point on that our left-hand table will be dependent on how we write our queries. In this situation, we're going to be doing this table, the dog table, as our left-hand side. So when this happens, if we're still trying to match on the owner's name and the dog owners, Kyle and Kyle still match to each other. However, all of the left-hand table, the dog table, will be shown, while the matching results on the right-hand table will only be shown for Kyle that actually has an owner attached to a dog in the dog table. I know that's a lot there, and it was a mouthful, but we will talk about this in a little bit. Remember, if you do have a question, feel free to type it in the lecture questions channel, and I'll definitely get to it. All right, so our full table will be shown, but with extra information from the dog owner matches. All right, so we got our left hand done. Let's talk about the right hand join. With the right hand join, it's exactly what happened last time, but completely opposite. We're still gonna match on that information with Kyle and Kyle, but only Waggy will be returned with their information, while all of the owner information will be returned on the right-hand side. And again, we'll see an example of this here in the near future, but just remember that the right-hand table, all of its information will be returned, while only the matching left-hand side will be shown. All right. Then we'll bring in common data to the table. So we'll bring in all of the common data from the left-hand side of the right-hand side, depending on which query you choose, into the as the result. Now, this is our left-hand side and our right-hand side joins. Let's talk about one more that's used more rarely than the other three. This is called the full join. When we do a full join between two tables, we take in all the information from both tables and just mesh it together to give one giant table or one giant query back. Now, this one's a little bit more rare because you don't want all that information meshing together. And it's so rare that MySQL actually doesn't support the full join. The full join, you have to actually write with a thing called a union in order to do it. So full joins are a little bit more tricky, especially in MySQL, but also rarely used. Of course, there are scenarios out there, and I'm sure some people in the development world are shaking their heads on full joins, but in all of the situations I've seen personally and also gone through, fulls are a little bit more rare of a scenario. So welcome to the join world. These are the 4 types of joins that are out there for the SQL scripts. Now, when it comes to these 4, we still want to choose one of these to attach our dog table with our owner table. So out of these 4, answer by yourself, which one do you feel would be the best to combine our information together to get the queries or to get the information together and mesh together for a nice query result? If you answered yourself inner, that is correct. Inner is the one we want to go with. We want to use the inner join in order to actually see all of these results. So let's go ahead and see finally an example of the inner join. So before we do that, we're going to have select, then dog name, then from the dog table. Everyone's seen this already. This is how we just select a dog name from the dog table. That's really it. But now we're actually going to do a join. To do that, the next word we use, because we're going to be doing an inner join, is inner. After inner, we need to define what exactly inner means to this query, and we're going to say inner join. After we say inner join, we have to say what table we want to join from. So in that case, we're going to say owner table. Now, this is the very, very important part. If we're joining 2 tables together, we need to tell it where to join on. We need to find that one portion of the information between tables that have a similarity. That similarity being the dog owner's name, whether it be Kyle or Teresa or Sarah trying to match those up. So in this case, we need to say next the conditional. In this conditional, we start with on, and then we provide what we're looking for. So we say dog table.dog owner equals owner table.owner name. That is how we tell SQL, hey, I want you to find the owner name in owner table and the dog owner in dog table, and if they match, return that query to me. That's what this is saying. So now that we have that, and now that I've babbled enough, let's actually see this in practice and make sure that I'm not just blowing smoke. So we're gonna come over here to our sheet. What I'm gonna do is gonna write this query, and you all are gonna help me. So wake on up, tell me this, how do I start writing an inner join? We're gonna try to do that selection of the two dog owners' names. How do I start it?
Select dog name.
Let me start with, oh, I'm not typing there. There we go. Select dog name, very good. And then what's
Dog
next?
table.
From
dog
table. Awesome. And then what's after that?
Inner join.
Inner join.
Awesome. Inner join.
Owner table.
Owner table. And then
On
On dog table.
dog table dot
Dog
owner.
owner name.
dog owner. And then
Equals.
very good. Owner table. Owner name. I'll give you that portion. So this is our conditional right here. Now, before we run this, I really want to just talk through it here. We have our select our dog name, which is the column, the dog table, which is the table, the inner join of what other table we want to join with, and then where we want to join on. We want to connect the dog owner to the owner's name. Let's go ahead and run this and see what we get. We get back Waggy, only the dog name, meaning we got one actual search result. We got back Waggy, who actually had a matching result in the owner table. Now that's cool, but I want to explain this a little bit more. Let's see all the information. To do that, what symbol do I use to say I want back all the information from the query? Who knows that one?
Asterisk.
Asterisk.
Excuse me, very good, absolutely. So we have the asterisk there. So let's go ahead and highlight that again, run it. And there we go, now we're getting back all the information. Take a very close look at this. We're getting back 9 columns, because 5 plus 4 is still 9. So yes, this is the 9 columns we're getting back from the two tables. They're meshing them up together. So we have Waggy, 7, Kyle, and then is good dog 0. And then we have the right-hand side here is owner ID, owner name, owner city, and owner age. So this is the inner join. It's finding the only matching result between these two tables and returning it. Awesome. So this is the inner join. I'm going to pause here. Anybody have any questions on this one? Anything at all?
Why didn't it return 2 names? Why only the one? Can I see your the other screen?
Yeah, absolutely. So let's go back over to that. So we are only doing, there we go.
Good job,
We are
baby.
doing these two tables.
Oh, okay, because Kyle is the only one that matches on both.
Exactly.
Okay.
It's basically an if statement we just wrote. If these two columns match, then return that result. That's what this inner join just did. So yeah, that's why you see only one name, because Teresa and Sarah don't have any matching, they don't match. So we can't do that. Cool.
Kyle?
Yes.
This may be a stupid question, but would the results turn up any differently if you took the owner table information first?
So if you switch dog table with owner table, is that what?
I think so. I was
let's
looking at the slide and I don't know if that's supposed to be just
so
flip-flop.
even if we switch this, we still get back those two because dog owner and dog, it's looking for dog owner in the dog table and owner name in the owner table. So even if you switch those two for an inner join, you'll still get back the same results. Does that help out?
So unless you're doing a left or right, it's just a matter of preference.
For an inner join, yes. We'll go over left and right here in just a moment.
Can you elaborate a little bit more on what she just asked? I'm still a little confused.
For sure. And Melanie, correct me if I'm wrong, but the question was around if we switch just owner table and dog table there, does that impact the results at all for this query for the inner join? And the answer is no. So what I did, if we just do a Control Z there, I switched dog table and owner table, just flip-flopped it just like that, still ran it, and we got the same results. That does not impact it for an inner join. Does that kind of help, Eva? Cool. All right, so I like this leeway into, let's talk about the lefts and rights. We said that it doesn't impact it for the inner joins, but it absolutely will impact it for the left and right join. So instead of an inner join here, we're going to switch it to a left-hand join, left side join. There we go. Let's go and run this. Run it and take a look at these results. We're getting back now 2 dogs' names, Waggy and Odie. Well, we only get back the one owner, Kyle, that's attached to Waggy. Again, that's because our owner names match, so we get back that dog information. But we said left-hand side, so we get back all the information on the left hand from the dog table. Now, this gives us a huge indicator for something, and something that we really need to remember as we move forward with these kinds of joins. Take a close look at this part of the query. In here, dog table is the left table in this scenario, and it will always be from dog table. Whatever is from is the left table. Whatever is after the join is the right table. From is the left table. After the join is the right table. This is very important because just accidentally flipping these two will get you completely different results. We'll see that now. We get that, and now we only get back one dog, but we get back 2 owners on the left-hand side. So to go a little bit further beyond that question that Melanie asked, for inner joins, it didn't matter where we put those 2 table names, but for left and right joins, it absolutely does. So we really need to make sure that we're looking at that and where we're placing our tables when we're trying to get back a certain query. All right, any questions on that?
So Kyle, the table in from is always the left table?
Right here is the left table. Yep, in front of the from.
Okay.
Yep, in front of the join is the right-hand table. So awesome. That was a left join. Let's go ahead and take a look at the right. All right, there we go. Run that. And now on the left-hand side, we get our dog back because that's our from table is the left, but we said we want all the information from the right table. So on our right table, owner table, we get back both owners, both Kyle and Sarah. So there we go. Our right-hand table returns all of the information from the right-hand side. So this is the difference between left and right joins, as well as we got to see that inner join too. Any questions at all on that? All right, then let's keep getting a little bit further then. There we go. All right, so we have our 2 owners here. I'm gonna go ahead and do that. There we go. Oh, perfect. All right, so we're gonna go a little bit deeper now. What happens if we add another owner? Take a look at this new table on the bottom now. On our owner table, we just added a second Kyle. This is way too many Kyles, but unfortunately for this, we're gonna have to hang on. We have 2 Kyles now in this table below. And how we do this is, actually, you know what? No, I want people to talk to me this. How would I insert this new Kyle character from Phoenix below? What do I have to write in SQL? Talk to me. Talk me through it. There we go. Insert. What's the next word?
Into.
Very good. Into. Awesome. And then after that is what?
The table name.
Table name.
Table name, very good. In this case, it's the owner table. And then what's the next keyword for an insert?
Values.
Very good, values. And then after that, we provide the values within the parentheses. So we say 3, Kyle, Phoenix, 42. Awesome. All right. Now for that, we're going to go ahead and just run that query real quick. We said insert into, we said owner table. And then we said values. And then I said 3, Kyle, said Phoenix. Oh gosh. Oh, Phoenix. Oh, I can't ever do that. There we go. Yep, I saw that right. And then 42. I think I forgot a parentheses or quotes there. I did. So that is our query right there. We're going to highlight all of that. I forgot a comma. Highlight all of that, then press that lightning bolt at the top, and it has been inserted. We're going to make sure by going to our owner table still, and then running this query. And we see now we have 2 Kyles, 1 Sarah. Cool. We are now matching exactly what we see here. Now let's go ahead and do a join. We're going to join these 2 tables, and we're going to go ahead and do Kyle again. So if I want to do that, I do a select dog name from my dog table. Apologize, I thought I changed that. But yes, from dog table, and then we say inner join owner table on our dog owner with our owner name. Now, when this happens, what's going to happen exactly? Well, let's see. In the dog table, we have 1 Kyle that's connected to this one, but there's also another Kyle that's attached to this one. This right here is a common scenario in the world because unfortunately there are more Kyles than just one. So this is going to make this blow up. Not necessarily blow up, but give us bad query results. Because Waggy belongs to me, well, it was also attached to this imposter Kyle over in Phoenix. We don't want this to happen. We need to change a few things in order for this to be a more structured architecture in our tables. So what I'm trying to get at is that we don't typically want to connect on names. We need to connect on something that's more unique. Something that people can't have the same ones of. So for dog owner, we need to switch to this to something that not another person is going to have. So when it comes to that, we don't want to do essentially maybe the owner's or the dog owner's name. We want to actually do their IDs because we looked in that owner table and what's actually unique down there are owner IDs. So we need to set our column to an ID. That's what we need to do here. So instead of our owner ID being Kyle, instead we actually need to set it to the real Kyle, which is ID number 1. So we switch Kyle to 1 there, and that connects to our actual owner ID in the owner table. So that is what we need to do there. One more thing I want to point out is that Teresa was not in the owner table. So what happens to Teresa? Do we just get rid of that entry? No, it's still good data. Teresa just doesn't exist in the owner table. She's not an actual owner that we know about. So instead, we actually transition this to null. If there is no corresponding owner or corresponding information in another table, it's typically referred to as null or entered in as null. So that's what we have there. Now our information is actually connected. So any questions up until that point? Anything at all? All right. So we're going to continue a little bit further then. We have a situation. We have 2 IDs in both fields. And right now we have to keep entering in these IDs constantly. But in our database, we want to make sure all IDs for every entry, no matter what table, stays unique between them. So we need to have something in our SQL database that keeps these IDs unique between tables. So let's go ahead and talk about that. What those are referred to as keys. Keys are things that keep our IDs unique inside of individual tables. The keys in particular that we're going to talk about that is special to that particular table is called the primary key. So in a table, we need to have something that we can rely on that is truly unique to each entry in that table. That thing we rely on is called the primary key. If we look at the dog table, we have to ask ourselves now, okay, out of all these columns, which one should be our primary key? This is a question you're going to be asking yourself as you move forward building your tables. You're going to look at your table, the structure of your table, and ask yourself, okay, which one is supposed to be the primary key? In this situation, I'm seeing our uniqueness is under the dog ID column. And yes, I probably gave it away by saying dog underscore ID. So we need to make something unique in our dog table. We need to make a primary key there. Right now, it's not set up. So the question we should be asking ourselves is, how do we exactly do that? So we're going to go ahead and have to make more changes to our tables. And by doing that, if we're going to be doing substantial changes to the architecture of our tables, we need to usually recreate it. If we're going to recreate a table and it already exists priorly, what we need to do is drop the table. This means basically delete the table. In order to drop the table, or in order to delete the table, we say drop table, and then of course, the table name that we want to drop. We're gonna be doing the owner table first, and then we'll go back to that dog table and finish that one. So we're gonna say drop table, owner table, and now we have to recreate it. In order to recreate a table or just to create one in general, not that I just said the word or anything, how do I do that? Tell me that. What keyword do we start out with?
Create.
Create
table.
Create table, fantastic. Third thing?
Table name.
Table name, very good. In this case, it's going to be the owner table. Awesome. Then we place that parentheses, and that's where we start defining our columns. This is where things are going to get a little interesting. So first things first, we have the owner ID. The owner ID is going to be our primary key, but how exactly do we set that up? Well, as always, we start with the column name, owner ID. We give a definition of what data type it's going to be, which is going to be int. And then this is where the magic happens. After this int, we're going to put primary key there. This tells SQL that this owner ID column is extremely special. It is the unique aspect of the table. It defines each entry. And these cannot be the same. You cannot enter in two rows with the same primary key, or with the same, well, yeah, with the same primary key, same ID. SQL will yell at you. So this is almost offering, if you will, a little bit of validation in your table architecture as well. Now, one more thing that we need to do, one more piece of the puzzle, is that we don't want to have to keep thinking about what number is going to be unique in these tables. We want SQL to do it for us. So in that case, we do auto-increment. So to review, primary keys are what keeps those entries unique. We cannot have two same primary keys. SQL won't let us. And then second, auto-increment will automatically create that primary key for us, increment from 1 to 100 or 1,000,000 or whatever. We'll keep incrementing that for us in order to create those primary keys that are completely unique between each other. So that is that one hefty line that is brand new to us. After that, it gets a little bit more back into the same stuff we were doing before. Owner's name is varchar of 50. Our owner's city is just a varchar of 80. Remember, these are just arbitrary numbers that we're choosing for our varchar length. And then our owner age, which is an integer, and then we close our parentheses. Awesome. Let's go ahead and actually see this in action now inside of MySQL. So let's go back over here and take a look. All right. So I want to go ahead and recreate my owner table. So what I'm going to do is what? I need to remove the table. What do I use if I want to delete it or remove it? What's that keyword?
Drop.
Drop
table.
Very good, everyone. All right, owner table. Fantastic. And we're just keep writing these queries because Lazy Kyle wants to just run them all at one time. So we're going to create the table now. How do I create the table? Talk me through it.
Create table.
Create table, table name, open parenthesis.
Speaking too fast. I can't even type that fast. All right, there we go. All right, let's go ahead and we're going to start with the owner ID. I will be nice and I'll even start you all out. Owner ID. All right, what's next? What kind of data type is owner ID? Int. There we go.
Primary key.
All right.
Primary
We want to make
key.
it the primary key. Primary key. Awesome. That is going to make that a special
Auto
column.
increment.
Auto-increment.
Exactly. We want to be lazy as we possibly can be. So we want SQL to auto increment our IDs for us. Very good. Not calling you lazy, just saying we want to save some time. There we go. Auto increment. That will now build our keys for us as we move forward for each row. Awesome. So after that, we're going to go and do owner and name, which is that varchar. I guess I put a 50. I don't know why I put 50, but whatever. No one's name can be bigger than 50. And then we said owner city, which was 80. Varchar 80. And then our last one was what? Owner age, I think. Age and INT. Awesome. All right. So there we go. Our queries are written. I'm going to highlight both of these. I'm going to then press the lightning bolt. And we have now done something. Where do we go? Oh, it's just covered up by Zoom, of course. There we go. We dropped the table successfully. We had that green light on 77, and then we created that table successfully on 78. Cool, everyone. We're on our way. One more thing I want to show you all is that now we need to insert our 3 owners back into the table. It's going to be a little different than we were before, but you've seen it in last class, but now it's actually going to come to some good use. So I'm going to go back over to the original query for this and grab those owners just to save us a little bit of time. Come back over to our owner table where you wrote this. I'm going to paste this. Now, take a close look. We didn't change anything to the query. You've seen this insert into table owner values. But now that our IDs are actually auto-incrementing for us, we no longer need to put the 1 in there. In fact, we should not, because we will get yelled at by SQL. But now that our values are different from our actual columns, we are no longer the default. So like it was brought up beforehand, we actually need to tell SQL which columns each of these values correspond to. So up here, we're going to put parentheses, and then we're going to type in the actual names of each column. So owner name, owner city, and then owner age. This now will refer to each of these values here in each spot. So 0th index, 0th index, first, second. That's how they correspond. And that's how we're going to do our inserts when it comes to these new auto-incremented tables. So I come up here, I highlighted, I press that lightning bolt, and we have now successfully inserted. Let's go ahead and make sure by coming up to our owner table, we're running that. We see that Kyle is now in here with St. Louis and 27, but with an ID of 1. I didn't have to put that ID in there. SQL did it for us. Isn't that cool, right? Blowing your mind on a Monday. You're welcome. Isn't that fantastic? Best thing you've ever seen in your life. Nothing. I get nothing. Oh my gosh. I'm gonna have to find a better way to blow everyone's mind. Fine. All right, let's do another one. Now that's gonna blow anybody's mind, but at least we can get this information in there. So we're gonna go ahead and run Sarah. We're gonna also take out that 2. Here we go. All right, run that. Our second owner has been inserted, and now we're gonna create that 3rd Kyle. And again, let's try to spell Phoenix, E-N-I-X. There we go, 42. That's too big of an age. There we go. Highlight that, run that. Fantastic. Oh, now we're gonna do that select. Cool. And now we have 3 entries in there. Awesome. We have now completely created this table once again. But now we actually have a primary key that's on the owner ID column. Now, if you're wondering what the symbol is, yes, it's there to easily see which column is a primary key, but you will also see this in some schematics and table diagrams with a key above a name of a column. This typically refers to as the primary key. So awesome. We have built the primary key. Now we have one more table to rebuild. Let's go ahead and build the dog table. Again, which one do we want our primary key to be? We want the dog ID column. That's what we're gonna do as the primary key. But, take a pause here, everyone take a breath, take a breath. I said but, so there has to be something coming, right? We have a situation, another one. Take a look at our owner ID column. owner ID now refers to something a little bit more powerful. It refers to our primary key in our other table. So this owner ID that's in our dog table is talking about our primary key in our owner table. That kind of chitter chatter means something in SQL. What we're referring to in our dog table, when we're referring to a primary key in our dog table, when we're talking about the owner table, what that's called is a foreign key. The foreign key is a key that exists in another table that isn't its own. So this owner ID that's in the dog table is technically the foreign key. And when we have a foreign key in our table, that has to be told to SQL. So things stay validated and stay structured. So that's what we're going to go ahead and start doing now. Let me get my thing up there. So in order to do that, we have to now tell SQL that our foreign key is going to be that owner ID column. So let's go ahead and do this. We first, as always, have to delete the original table, dog table. If you're asking yourself, do we always have to delete it? No, there's ways of altering it, but because we only have 2 entries in there, I'm just gonna delete it and make it again. It's not gonna be that big of a deal. If you have something that has 10,000 entries, you typically wanna alter it with the alter keyword. But in this case, we're gonna just drop the table, dog name, and then we're gonna recreate it with that create table dog name. Now we're creating something with a primary key. So we already have our dog ID there. That's gonna be an int, but I want my dog ID again to be that primary key. So what keyword do we typically use if we're gonna set a primary key? You're just mouthing it to me. Very good, primary key. But what keeps our stuff auto? Oh my gosh, I need to stop using the answers. Thank you. Just giving you guys all the answers today. Wow.
Right.
All right. Auto increment. Very good. You know, at least you remembered it. I'll take that. So yes, we want to auto increment in order to keep that going automatically for us. After that, same thing. We have our dog name, varchar 40. Our dog age, which is int. We keep these columns exactly the same, nothing weird there. Our owner ID, which again is going to be int. Crazy enough, we don't have anything going there. Just you put owner ID int, that's fine. And then we say is good dog Boolean. But this is where the fun part begins. We know owner ID that we made up there about a line above is a foreign key. And we need to tell SQL that it's going to be. So how we do that is we start with the keyword foreign key. What we're telling SQL here is that we are about to create a foreign key, so pay attention. After that, we need to define what it is. So we say foreign key is going to be owner ID. And SQL is going to be like, cool, okay, owner ID is going to be a foreign key. Can you tell me a little bit more? And we're like, okay, calm down. We sure will. What we're going to do is we're going to reference the owner ID in the owner table. And that's how we do that. We use the keyword references and we say the table name and what column within that table actually belongs to that foreign key. This is the glue that attaches the foreign key in the dog table with the primary key in the owner table. You just glued them together, just like that with that line. Mainly using that foreign key keyword. That will denote where in the table, where in your dog table, the foreign key is. And then we say, okay, that foreign key that we have in our dog table is referenced to the owner table. And inside the owner table, it's the owner ID column. That's what that line is saying. So with that in mind, let's go ahead and we are going to create that now in my SQL. So we're going to come down here. As always, I'm going to give this one to you. We have drop table. I'm going to say dog table. Getting rid of all of our dogs just for a second though. Drop table, there we go, semicolon, highlight that, press R, lightning bolt, and our table has successfully been deleted, dropped, removed, whatever you want to call it. The next thing we need to do is actually create the table. I'm also going to do that one for you because I'm a nice person. Look at that, if I can even spell, create table, and then dog table. Now this is where I'm turning it over to you all. Help me create our primary key, which is going to be dog key or dog ID. What comes next after dog ID?
And primary key.
And the data type, always. Very good. Next is?
Primary key.
Primary key.
Very good. Primary key, we need to let SQL know this is going to be that special column. After that,
Auto-increment.
very good. Auto, and also just remember this, auto_increment. Do not put a space there. That will just throw everything off. Auto_increment, very good. All right, after that, we got the dog name, which is the varchar of, what did I say, 40. Awesome. And then we have our dog age, which is an int. Owner ID, an int. Okay, quick question, pop quiz. Do we do anything extra on this line for owner ID?
No.
Yes, it's the foreign key.
We do not. We are not going to do anything on this particular line. We do all of our foreign keys at the bottom. So owner ID int, that's where we're going to put that. And then we have one more, is good dog. And that's going to be that bool. Very good. Now this is where that magic happens with that foreign key. So I'll start us out. To start defining the foreign key, we start with foreign. I got to remember to spell foreign. F-O-R-E-E-I-G-N. Foreign key. And then what comes after that?
Owner ID.
It will be owner ID. We're going to be referring to which column the foreign key is in. This is going to be referring to our foreign key. So I'm going to copy that column name. So this refers to our table. Where in our table that we're creating is that foreign key going to live? It's going to be an owner ID. Now, what's after this? What's next? References. Very good. And then what do we do for references? What's after that?
Owner
Table.
We refer to the table that that foreign key resides in, or that primary key that it's referring to. So owner table, very good. And then parentheses. And then what goes in here?
Owner ID.
Very good. The actual column within that table, owner table, what it's called. So if it was referred to as something different in owner table, this would have to change. Remember that. I know it's kind of hard to see because the name in our dog table and the name in our owner table are the exact same, but these two are referred to differently. This owner ID refers to what's inside of our table that's being created. And this owner ID refers to what's actually in the owner table, what it's referred to as. And that officially is the glue that, again, attaches those two columns together in the two different tables. So let's go ahead and highlight that, and we're going to run that. Make sure that runs properly. Fantastic. So now we have officially added our new dog table with a lot more validation and structure. Those two pieces of structure being the primary key that always has to stay unique, otherwise SQL will yell at us. And the second thing being the primary or the foreign key. So if we try to enter in a foreign key for an owner, it has to exist in the owner table, otherwise SQL is going to be pretty upset with us. So let's go ahead and try to insert some information into this new table. First, I'm going to come up here, I'm going to refresh, come down here, and I see my dog table and my owner table. Right now for my dog table, I have nothing in there. So I'm going to run this query here to selecting everything. I have nothing in my dog table. In my owner table though, if I go all the way back up, I have those three owners with the IDs 1, 2, and 3. Now for this, what we want to do is go over to the owner table, and we want to go to the other owner table. There it is. We're going to come down here where we created our dog table, and what we're going to do is now insert information into it. So we're going to say insert into, and then the name of our table, which in this case is the dog table. Insert into dog table. Awesome. And then what comes next is, because we have that auto increment on, I actually need to define what columns I want to supply information for. In that case, it's going to be dog name, the dog age, the owner ID, and is good dog. Just like that. And now we have to actually provide the information. In that case, we say values, and we actually give that information. Our first dog name was going to be Waggy, I believe. The dog age was like 4, I think. Our owner ID was Kyle. Kyle is owner ID number 1. So I have to put a 1 here. I can't attach Kyle anymore because remember, this owner ID is the foreign key and it's looking for owner ID, the int. So we have to now say 1, which is right here in this owner table. And then after that is good dog. For this one, you know what, Waggy, Waggy was not being a good dog. I forgot about that. There we go. So this is our insert statement for our new super awesome table we just created for our dogs with the foreign key and the primary key. Let's go and run this and see what happens. Looks like it was successful. Awesome. Let's go and check out our dog table just to make sure. We run this. We see that Waggy has successfully been inserted. Awesome. Now, this is cool. We've seen how to insert information before. It all works the same with the foreign key, but let's see what happens when we actually try to insert information to a owner ID that doesn't exist. So if we have our dog name as Toby, good old Toby, Toby's gonna be 7 today, and he's gonna try to attach himself to owner ID 100. And Toby's always a bad dog, so Toby's gonna stay at a 0 there. We're gonna go and highlight that, and we're going to run that query. Take a look at this. On 90, this was unsuccessful. If we read this, it says cannot add or update a child row. A foreign key constraint fails. A foreign key constraint fails. This is telling us that the foreign key that I supplied while trying to insert Toby failed, meaning that foreign key or the primary key in the table it's referring to does not exist, which is completely correct. We only have 3 owners. So our owners are 1, 2, and 3. I try to say attach it to owner 100. That ID doesn't exist. SQL will fail. This is right here how we provide that structure in our SQL databases to protect us against bad data. And that's why this is extremely important in any SQL structure. So right there, I'm going, oh, you know what? That is why I'm not seeing any questions today. I'm on the videos channel. I apologize. Okay, good, I haven't missed anything. No, I have. I totally have. I apologize. I have been missing questions today. So I'm going to pause here and actually get to these questions, and they've already been answered. If you initially create a varchar 80, can you later change it to varchar 120 without causing any issues? If so, can you change it from 80 to 40? You can go up from 80 to 120. Going down is more risky. I believe you still can, but I don't know exactly for sure. You can increase the space, but you typically don't want to decrease, because if you have 10,000 rows of information, you're gonna have to go and validate that each of those rows stays in that constraint of 40 characters. So you typically can edit your table's structure anytime you want, but if you decrease size, it's more risky of a path. So Darren, great question. Yeah, it is possible, but it is risky. Can you have more than one foreign key if you are combining several tables? You absolutely can. You can have as many foreign keys as you want in a table, but you can only have one primary key. If for whatever reason, maybe we have a toy table that we want to know what toy is the best for each dog, we can attach a toy table using a foreign key as well. Yeah, we can have as many foreign keys as we want. Great question there too.
Kyle?
I heard a question, but your screen didn't pop up. So what's going on?
Oh, okay. I just wanted to add something onto that. So if you have more than one, shit, I just lost it. Damn it, I'll get back to you.
Okay, sounds good. All right, Wima, I see. So it would work if you put into, and I apologize, I'm trying to, oh, you're talking about the insert into for the owner ID. Let's go ahead and see what that would do. So maybe Toby's owner is going to be the Kyle in Phoenix, the imposter Kyle. So if we go ahead and highlight this and then run that, we see that we get back a green light. So yeah, we are able to do that. So yep, it will definitely work for 2, but if we try 3, we'll get back that error. One more thing I want to show you guys too.
All right, Kyle, I had another part to that question. So if it'll work if you put in 2, what if you do another insert in 2 and then you do 2 for that one? Will it just override it or will it give you an error?
Say it one more time. 2 going and where?
The owner ID. So you put 2 in that one and it took it. But if you do another insert into under that and put another dog name, another dog owner, but you still put in the same owner ID, will it override it or will it give you an error because you already put one in there?
Neither.
It
It
should
will
be
actually
another
just
entry
add
in the
that.
table.
Yep, it will actually add another entry into the table with that same owner. And there's no constraint around that because one owner can have 2 dogs. So yeah, that's absolutely fine. So we go over to our dog table and we do that. We now have Stark in there too, and they are both attached to the same owner. So yeah, that is A-okay.
Okay.
Yeah. We'll learn in the future how to actually provide some more structure around that because maybe we want one owner to have 2 dogs, but we don't want to have one dog to have 2 owners. And we can add additional constraint around there in future chapters. And it might actually be next lecture. I don't know for sure, but no, as of right now, how we have it set up, it will work. Cool.
I remember my question.
What's going on?
Okay, so if you have more than one foreign key, do you have to list them all because you made them primary keys in their own tables? Or is it just if you need the information from that particular column when you join them?
So if you were to do 2 foreign keys, what you want to do is you're going to come to this portion right here. And I think I had to always look up the same syntax, but I believe you're going to do another one. You say foreign key, and then you'd say like, I don't have the other table created, but you'd say foreign key. And then instead of owner ID, it would be like toy ID. I just want to write this out for myself too. References like toy table or something. This is just referring to an arbitrary table that we created if we were to toy ID, something like that. Oh, yep, my bad. There we go. So you'd refer to it as two different foreign keys.
And you have to label them all if they're on there. Like once you put a key on a column, you have to reference it.
Kyle, she's asking about design. If a table has a primary key, do you have to make a foreign key in another?
Yeah, and I'm trying to think of the best way to answer that. The answer is yes. Typically, you do. You want to do that to provide that structure. So if you have two tables talking to each other, or have data that corresponds to each other, you want to set up that foreign key as well as that primary key. So yes. Do you have to do it in order for it to work? No. And I hesitate to say that, but you want to. And it is highly, highly, highly recommended that you always set up your foreign keys when doing two different tables.
But if you say you have your ID, your owner table and your dog table, and you want something from the toy table, but not necessarily the column that's been keyed. Do you know what I'm saying?
I'm trying to understand exactly. So if you're in the toy table, and you have three different toys, IDs 1, 2, and 3. In that situation, I guess give me more to your question.
Okay. So you made toy ID the column that's keyed. Say you have like toy shape and toy material or something, and you want information about the toy shape. Mm-hmm. Do you still have to write it out that the toy ID is the keyed column?
Yes, because we know that two toys can have the same shape. If I have two toys in my table that are round, how do I know which one I'm referring to? Other than using the ID itself.
Okay.
So that's why we want to keep those. So yeah, we want to always use the IDs when we're referring to other information, just in case there is duplication. And if I'm not getting at your question too much, just let me know and we can talk about it to offline.
So it's
as
always
well.
going to need something that has unique value to give.
Absolutely.
Okay.
That is how all structured data always is. You should always have a unique identifier because everything else in the world can be repeated. The only thing that shouldn't be able to be is the unique ID. So anytime you're designing any kind of system, you should always have a unique identifier for everything.
All right, thanks.
Yeah, absolutely. Great question. Yes, that hits me in the heart too, because I have some people that design things without an ID. It's like, no, you need an ID because everybody can duplicate information. Same name, sometimes even same social security numbers that happen once. Like you got to find another kind of identifier. It's craziness. All right, but cool, great question. I'll stop myself from going on a rant there. But let me see what else we got here. References. So let's go ahead and just review real quick what we did. So for our dog ID, we made that our primary key. For our owner table, we made our owner ID the primary key. Now take a close look at this one. In our owner ID, we made that the foreign key. Typically, you'll notice that as an outline of a key in a lot of schematics. This is telling us that this owner ID foreign key refers to our owner ID in our primary key in our owner table. So that's what we did today. We attached that table to this one with that validation and structure. And honestly, that is a big feat in itself. So that's how we do it with primary keys and foreign keys. And we can always query it all with joins.
So the foreign key is the owner ID, right? And it's referring to the primary key in the owner table.
Very good. Yes, absolutely. The foreign key is the owner ID in the dog table that refers to the owner ID, the primary key in the owner table.
Okay, makes sense.
Awesome. Well, with that one, that's all we got. That is it for today. So any final questions here? Any final questions on joins? Because we went over those inners, rights, lefts, fulls. If you guys are really interested, I can show you how to do a full join. It'd be so fun in MySQL. And then,
question.
of course, yes, what's going on?
The exercises had us doing an inner join on an inner join. I suppose just because you have to know that it's possible and that helps you understand things. Because you were grabbing something from a third table while combining the two, and it was really complicated syntax. But I sort of posted on this in social media, like, I'm doing inner joins and inner joins. It's not even legal in most states. But a buddy of mine who does this sort of thing for a living said that if you have to do an inner join on an inner join, there's probably a better way to design your data flow in the first place. So I just wanted to get your take on it.
Technically, that's true. Yeah, if you're doing inner joins on inner joins, you can possibly optimize it a little bit. But there are a lot of cases that does happen.
Okay.
There could be more complex queries. So they might not be as prevalent, but why he said that, or why they said that, is that an inner join really adds a lot of time to a query. In my development, I have queries that take a few days. So
really?
Yes. So
Wow.
because there are a lot of data points out there and there's a lot of data, and SQL is slower of a language because it has to go line by line. So the less inner joins, the better.
So runtime's not log in. We're dealing with just like big O time of in or something for some of these things?
I would say it would be on nearly exponential. It depends.
Okay.
It would be 2. But it
Okay.
depends
Oh my gosh.
on what you're
All right.
doing. Yeah.
That's cool.
Yeah. It's fun to wait for queries. Just like hope that your computer doesn't die as it's running. Can you combine data from tables from different schemas? Oh, that's actually a good question. I always forget. Let me see. Now I'm curious. Good question, Darren. Got me at the last thing. Combine data from two different schemas. Let's see. What do we got here? Data merging. Oh, you can't. Oh, well, let's see if we can do the merge from two different schemas. Boop a doop a doop a doop. Technically, I would say I would not recommend it. I think because they're on the same server, it is possible because your schemas exist in the same location, but it's not fun, to say the least. So possible, not fun. I say don't make it a weekend project. Well, you can make it a weekend project. Don't make it a Monday project. Don't have a bad Monday. But if you're bored on a Sunday, feel free. I've never done it, so I have no idea. But it looks like it is possible. Good question. Anything else, everyone? All right. In that case, then I am going to be done talking here. Thank you, everyone, for joining me today. Let me try to think. Got anything? Yeah, studio is going to be out there at 8:15 tonight. If you have any questions, as always, feel free to Slack me. I have time on my calendar really too if you want to set up any one-on-one time. Other than that, have a fantastic week, and I will see you all back here on Thursday. Enjoy your studio night. Thanks, everybody.
Jake,
Thanks, Kyle.